Applications of Pythagoras Theorem. Pythagoras Theorem can be applied to acute angled and obtuse angled triangles, and we have interesting results with respect to these triangles. In acute angled triangle ABC, if segment AD is perpendicular to side BC, points BD and C are collinear, then AC square is equal to AB square plus BC square minus 2BC into BD. Proof. In right angle triangle ABD, AB square is equal to AD square plus BD square by Pythagoras theorem. Mark this as statement 1. Also in right angle triangle ADC, AC square is equal to AD square plus DC square by Pythagoras theorem is equal to AD square plus in bracket BC minus BD whole square, as points B, D and C are collinear, is equal to AD square plus BC square minus 2BC into BD plus BD square is equal to in bracket AD square plus BD square plus BC square minus 2BC into BD is equal to AB square plus BC square minus 2BC into BD from statement 1. Thus, AC square is equal to AB square plus BC square minus 2BC into BD. In obtuse angled triangle ABC, angle B is greater than 90 degrees. If segment AD is perpendicular to side BC and points DB and C are collinear, then AC square is equal to AB square plus BC square plus 2BC into BD. Proof. In right angled triangle ADB, AB square is equal to AD square plus DB square by Pythagoras theorem. Mark this as statement 1. In right angled triangle ADC, AC square is equal to AD square plus DC square by Pythagoras theorem is equal to AD square plus in bracket DB plus BC whole square, as points D, B and C are collinear, is equal to AD square plus DB square plus 2BC into BD plus BC square is equal to in bracket AD square plus DB square plus BC square plus 2BC into BD from statement 1. Thus, AC square is equal to AB square plus BC square plus 2BC into BD. Coming to the Apollonius Theorem. Apollonius Theorem is a theorem relating the length of a median of a triangle to the length of its sides. The theorem is named after Apollonius of Perga. In triangle ABC, if segment AD is the median, then AB square plus AC square is equal to 2AD square plus 2BD square. Here, we shall prove this theorem for an acute angled triangle using the applications of Pythagoras theorem. Given, in triangle ABC, segment AD is the median. To prove, AB square plus AC square is equal to 2AD square plus 2BD square. Construction. Draw segment AE perpendicular to side BC such that points B, E and D are collinear. Proof. In triangle ABD, if angle ADB is less than 90 degrees. By using application of Pythagoras theorem, we get AB square is equal to AD square plus BD square minus 2BD into DE. Mark this as statement 1. Now, in triangle ADC, angle ADC is greater than 90 degrees. Therefore, AC square is equal to AD square plus DC square is equal to 2DC into DE by using the application of Pythagoras theorem. Thus, by substituting BD for DC, we get AD square plus BD square plus 2BD into DE. Mark this as statement 2. Therefore, by adding 1 and 2, we get AB square plus AC square is equal to 2AD square plus 2BD square. Hence, the theorem is proved. Let us solve few examples. Example 1. In triangle PQR, M is the midpoint of side QR. If PQ is equal to 11, PR is equal to 17 and QR is equal to 12, find PM. Solution. In triangle PQR, segment PM is the median. Therefore, QM is equal to MR is equal to 1 upon 2 QR is equal to 1 upon 2 into 12 is equal to 6. Now, by Apollonius Theorem, PQ square plus PR square is equal to 2PM square plus 2QM square. 11 square plus 7 square is equal to 2PM square plus 2 into 6 square. 121 plus 289 is equal to 2PM square plus 2 into 36. 410 is equal to 2PM square plus 72. 410 minus 72 is equal to 2PM square. 338 is equal to 2PM square. 169 is equal to PM square. Therefore, PM is equal to root of 169 is equal to 13. Therefore, PM is equal to 13. Example 2. Prove that the sum of the squares of the diagonals of parallelogram is equal to the sum of the squares of its sides. Given quadrilateral ABCD is a parallelogram. Diagonals AC and BD intersect each other at the point E. To prove AC square plus BD square is equal to AB square plus BC square plus CD square plus AD square. Solution. Diagonals of a parallelogram are bisectors of each other. Therefore, AE is equal to EC and DE is equal to BE. Call this statement as 1. In triangle ABC, segment BE is the median as E is the midpoint. Therefore, by Apollonius Theorem, AB square plus BC square is equal to 2BE square plus 2AE square is equal to 2 into bracket 1 upon 2 BD whole square plus 2 into bracket 1 upon 2 AC whole square by statement 1 is equal to 1 upon 2 BD square plus 1 upon 2 AC square. 2 in bracket AB square plus BC square is equal to BD square plus AC square. Therefore, AC square plus BD square is equal to AB square plus BC square plus DC square plus AD square, as AB is equal to DC and AD is equal to BC. Let's start with exercise 1.7. Question 1. In triangle ABC, AP is a median. If AP is equal to 7, AB square plus AC square is equal to 260, then find BC. Solution. Given AP is equal to 7, AB square plus AC square is equal to 260. By Apollonius Theorem, we get AB square plus AC square is equal to 2AP square plus 2BP square. Now, by substituting the given values, we get 260 is equal to 2 into 7 square plus 2 into BP square. Therefore, 2BP square is equal to 162. BP square is equal to 81. BP is equal to 9. Now, P is the midpoint of BC as AP is the median. Therefore, BC is equal to 2BP is equal to 2 into 9 is equal to 18. Thus, BC is equal to 18. Question 2. Adjacent sides of a parallelogram are 11 centimeters and 17 centimeters. If the length of one of its diagonals is 26 centimeters, find the length of the other. Solution. It is given that AB is equal to 17 centimeters, BC is equal to 11 centimeters, AC is equal to 26 centimeters. Diagonals of a parallelogram bisect each other. O is the center. Therefore, AO is equal to CO is equal to 13 centimeters. In triangle ABC, BO is the median. Therefore, by Apollonius Theorem, AB square plus AC square is equal to 2BO square plus 2AO square. By substituting given values in the equation, we get 17 square plus 11 square is equal to 2BO square plus 2 into 13 square is equal to 289 plus 121 is equal to 2BO square plus 2 into 169. 410 equals to 2BO square plus 338. 2BO square is equal to 72. Therefore, BO square is equal to 36. BO is equal to 6 centimeters. Now BD is equal to 2 into BO is equal to 2 into 6 is equal to 12. Thus, BD is equal to 12 centimeters. Question 3. In the figure, angle PQR is equal to 90 degrees. T is the midpoint of the side QR. Prove that PR square is equal to 4PT square minus 3PQ square. Solution. It is given that angle PQR is equal to 90 degrees. QT is equal to TR. Therefore, PT is the median of triangle PQR. By Apollonius Theorem, we get PR square plus PQ square is equal to 2PT square plus 2QT square. Assume this as equation 1. In triangle PQT, QT square is equal to PT square minus PQ square by Pythagoras theorem. Assume this as equation 2. Now, by substituting equation 2 into 1, we get PR square plus PQ square is equal to 2PT square plus 2 into bracket PT square minus PQ square. Therefore, PR square plus PQ square is equal to 2PT square minus 2PQ square. Therefore, PR square is equal to 4PT square minus 3PQ square.